Alright, in this video, we're going to talk about the Otsu Binarization method in OpenCV using Python. So we'll start off by saying what it is, why do we need it, how does it work, and jump straight into a coding example. So by the end of this video, we'll see how we get this image on the left to this image here on the right. So what is it? So a thresholding technique that tries to separate the foreground and background. So that's the main idea, is to separate the two. But in some cases, it may not be exactly that, depending on the situation. But the key idea, I would say, is that it's trying to separate the histogram into two classes. Okay, so I would say that's the main idea. So why do we need Otsu? So the main reason why you might need it is for uneven lighting, but more so, it's an automatic way to threshold. So sometimes if your picture, you might not know the exact threshold value and you need some automatic way to do it, this might be the way for you. Okay. So how does it work? The way it works is you want to first compute the histogram. So here on the right, you have a histogram that you calculated. And the way you want to go through this is you want to iterate through all the possible threshold values. So if I were to have a line, just imagine if I'm like essentially testing out each of these different possible threshold values. And then for each of these values, we want to find the threshold value that minimizes the weighted in-class variance, which is this sigma W term here. So we have this equation here that we're trying to minimize. And we want to see which threshold value give us the min value for this equation here. Okay, so that is the key idea. And once we find that value, we will threshold the image with that value. Okay, so some of the equations here, you can see you have the Q term, and then you have the mu. So Q here is used based on the probabilities, and then it's a cumulative sum. So here you have I to T, and then here's T to I to the max intensity. And then mu is the mean, so this is the equation for the mean. And then the sigma term here is gonna be the variance essentially. Okay, so that's where some of the Q term here is used to calculate it. Okay, so Q is used and then mu is used. So even though mu doesn't show up directly in this equation, Q and the sigma squared here is used. Okay. So we won't go into too much details about the derivation, but the main idea is we have this equation here and we're going to minimize it. Okay, so let's jump straight into the coding. Okay, so as usual, let's go ahead and import the modules that we need. So we have here import cv2 as cv, and then import numpy as np, import matplotlib.pyplot as plt, and then import os. So we're going to call this Otsu thresh for short. And then we have if name equals main. And then we're going to call this Otsu thresh. So inside here, let's go ahead and read our image. So root equals os dot get cwd, and then our path equals os dot path dot join, and then we'll pass in root. And then we have our image and demo images, and we have our tessa.jpg. Okay. And we have our grayscale image, which we'll do cv.read, and we'll pass in image path and then give it the cv.read grayscale. Okay. So that's our grayscale image. And then let's go ahead and plot some of the stuff so we can see what's happening. So create our figure, make a subplot here, 131, and then plt.show. And here we're gonna pass in the gray image, and then we have our C map is gray. So we can see the original image. I'm just call this gray here. And then here, let's do a plt.show. So let's see the image that we're dealing with real quick. Okay, so that's the image we're dealing with. So now let's go ahead and show you the thresholding. So we'll go ahead and show you the original global threshold, and we'll see how we could tweak the threshold value to see how it ends up matching the Otsu. So let's see what happens. So let's do create our subplot here, and then inside our subplots, we're gonna do a 132 here. So we have our 132 and then thresh equals 70. And then we have our max value equals 255. And we're gonna pass in our image threshold CV dot threshold. And we're gonna pass in our grayscale image. And we have our threshold value that we set to be 70. We have our max value. And then the type we're doing is going to be cv.thresh binary. Let's see, max val, I have a capital V here. Okay, so that's the method we're using. And then that looks good. So now we're going to do our plt.show and let's see, show and then pass in our image thresholding. And I'm going to do cmap gray. Okay, so if I run this, we should see our global, right? So we could add in our title here, global, just so we know what it was. And then let's go ahead and create one for our Otsu. So our Otsu is going to be actually kind of similar. We have the, it's going to be some arbitrary value that we'll see. So I just duplicated this and then we're going to make this a 3. Our max value is the same, right? But here, I'm just gonna call this arb thresh, and it's just a placeholder because for Otsu we actually don't need it, so I'm gonna call that arb thresh. And then the only tweak you need to do with the normal thresholding here is now you do a plus and then you do cv dot thresh, and you can see there's an Otsu option. Okay, so when you add these two options, you're gonna be doing the Otsu method. So here, just to make the distinction, I'm going to call this image Otsu, and I'm going to replace this as well. So that will give us our Otsu method. So let's go ahead and see what that looks like. Okay, so if I run this, we see that Otsu gives us this diagram here. Okay, so you can see it segments the car a little bit better. You can see this like bright spot kind of goes away in the Otsu method. And but the thing is, you see this like black blob here, right? So sometimes Otsu could be good, but again, you're gonna have to see if that's the result you want. So here we're gonna see how we could tweak this threshold value in our global one to match the Otsu. Okay, so we'll do this a little bit with we'll just tweak the value and see, but let's see where the actual threshold value for the Otsu corresponds to in our histogram. So we have our histogram as cv dot calc hist here. And we're going to pass in our image gray inside a list. And then we have 0 for the channels. And then mask, we're not using anything. Histogram size is 256. And then the range is going to be from 0 to 256. Okay, so that's our histogram. And then plt.figure. And then plt.plot. I'm going to plot our histogram. And our x label, this is our intensity. And then our y label is our number of pixels. And then we have our show already, so we don't need that. So if I run this, we see that this is 70, right? So if you guys recall from previously, 70 is somewhere in the dip of our image. So let's try to increase this. Let's say like 100, see what that gives us. Let me close out the previous figures. So if threshold is 100, you see that these two are starting to look pretty similar. So 100 is like somewhere here, right? So what that tells us is Otsu probably calculated a threshold to be somewhere around 100. So that's why these two images are starting to look closer together. Okay, so that's just a pretty interesting way to kind of back calculate or by comparison of the results to see what the threshold value could have been calculated for the Otsu. Okay, so if you found this video helpful, give a like and subscribe, and I'll see you in the next one.